Good morning. Let's start today's class. I think day by day attendance is becoming very poor.
Good morning,
Anyway,
sir.
good morning.
Good morning, sir.
Anyway, so let me start by sharing. Is the slide visible now?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
so today I'm going to start another interesting feature of programming. I mean, it is not only C, almost all programming language offers one very interesting feature that is related to organizing data. As we have mentioned it several times that in programming we'll often deal with data. We'll compute based on compute some operations, and that will be performed on data. Now, just like we have seen that when we have to do similar kind of operations on a set of varied data, we can use the properties of iterations like loops. Now, when we need to deal with a collection of large number of similar types of data, then instead of storing them or keeping them as individual variables, we can club them in a single variable. Okay, and we can refer them as a collection and at the same time as different entities. Okay, so these type of collections are often required and will be very helpful in programming, and the programming languages offer that type of collection as a data structure called array. We'll discuss how and why it is needed first, and how we can in C we can implement array and use them in our programming. Okay, so that is the whole idea. In today's class and upcoming few classes, I am going to
Sir, sorry to
discuss about that. Is there any problem?
sorry to interrupt, sir. Are you recording this meeting?
Yes, actually I am recording through OBS, which is in my local machine. Actually Joydeep sir is not there
Okay,
since
okay,
his
okay.
host Google Meet is not allowing me to
Okay, sir.
record. Okay, I am recording. Don't worry. So let us start with a
Okay, sir.
motivational exercise so that you can really understand why we should need this type of organization of data. Okay, then we will see how in C we can implement that. So let us take up this simple problem. Okay, instead of now writing a program to find out sum or average, I am changing the program a little bit. That you are given you are asked to write a C program that takes say 9 numbers. 9 is a just representative number as input, and then computes and prints the standard deviation. Now I think all of you know what is the formula of standard deviation. If you have forgotten, then you can see this. When we have a set of n numbers, x1, x2 up to xn, this is the formula for computing standard deviation. What we have to do? We have to basically first compute the average. Okay, and then we have to find out the difference of each of these number from the average, and that may be positive or negative depending on whether that individual number is less than the average or greater than the average. But anyway, we'll make a square so that all the components will become positive, and we'll sum up all of those components. Okay, that what we call variance, and then we'll divide it by the total number of numbers. Let's say n number is there. Okay, and then we'll take a square root of that. So agreed this formula of standard deviation. Now we will try to write the desired program in C. Let us try. Let us try to write that. So what will be the major steps here? So I have to read the 9 numbers first from the user. I have to write a suitable statement in C so that I can write, probably writing one or more scanf statements. Okay. And I have to compute the sum and average. Obviously, average computation requires the sum. Actually, I need to calculate average. Okay. And then I'll go for computing the standard deviation following that formula. Agreed. These are the major steps. Hello.
Yes,
Okay.
sir.
So let's try to write down the program. So I am starting. So I have written these variables. I mean, I have started declaring and initializing these variables which I need. And then this is the way I can get those numbers. Okay. To this is how we compute sum and average. This portion is known. We have already taken up this problem several times. Okay. Is this part okay? Up to this
Yes, sir.
computing average.
Yes, sir. Yes.
Now once I have, so these first two steps are done automatically. Now once I have got the average, now I can now compute the standard deviation. Now see, I am stuck in a problem because now I need all these individual numbers. See, in order to compute sum or average, I have used only one variable to store 9 numbers. Each time I am getting one new number, I am using that number to get the new partial sum, and next time I am coming, I am overwriting the content of that x for the new number because I have already taken up or consumed the earlier number. So if only average was to be computed, then it was okay. Because once I have got the number, I have already performed this particular operation. I am done with that number. I don't need that number again. So I can safely overwrite the content of that number with the new incoming value. Understood? But here, in order to compute standard deviation, I need all the 9 numbers because I have to calculate the variance by subtracting average from each of those 9 numbers. Now I am in a problem because I have not stored those numbers anywhere. Those numbers are lost. Only the last number or ninth number is available within this X. Understood the problem?
Yes, sir. Yes, sir.
So if I just follow the same principle, same code and try to edit that to find out the standard deviation, I will not be able to do that. So what is the solution I have?
Sir, I have to declare the 9 x1, x2, x9.
Exactly. So far whatever we know, so instead of taking this only x, I had to declare 9 variables, separate variable x2, x3 up to x9, and then I had to use this scanf statement 9 times to scanf each of these 9 numbers, and then I have to compute sum equal to this formula using this formula. Okay, and then average, so that after computing the sum or average, still I have all the values stored and available with me, so that I can compute this variance and finally the standard deviation. So the knowledge so far we have, I mean, this observation I have already pointed out. So this is the way so far whatever we know. Okay, but look at this, for 9 numbers it may be okay. But if I had to find out, because as I have mentioned several times, the ultimate goal of writing a program to deal with a large number of problems, like it may be 900 numbers or 1 million numbers, I have to find out the standard deviation of 1 million numbers or say all 900 numbers or 90 numbers even, then declaring and taking 90 numbers one by one and follow this strategy will be very cumbersome.
Yes, sir.
Understood? So, but fortunately, all programming languages offer the one way to tackle this problem in better way. That means when we need this type of uh, things, that when we are dealing with same types of data, a large number of same types of data, and we need to store them, all of them, instead of declaring separate variables for them, we can make a collection, and as if we can store them as a single variable. It may not be called as a variable, it is called a data structure, an organization, where we can refer them, we can store them with a single name. Okay. And we can refer each of the individual values of that collection by some means. Okay. And that is what is called arrays. Okay. So instead of declaring these separate 9 variables for this program like this, I can organize them like a sequential collection of 9 elements or 90 elements or 900 elements, whatever be the size I need. Okay. And I can refer with a single name. So this is a declaration of an array, which is equivalent of storing 9 different integer variables. Logically, it looks like a list, sequential list. Okay. So let us see how, what are the rules or syntax of declaring and using them inside our program. So you have already witnessed that this may be the way how we can declare. Like when I declare a normal variable, I am declaring it like x1 semicolon. What is the difference? Here I am declaring int x within square bracket 9. Look at this. Just like in this case, here also I need to mention the data type. This collection can only be made of several data items of same data type. I cannot mix int with float in this collection. That is one restriction I need to keep in mind. Okay, so all of them should be integer type, or all of them should be floating point type, all of them should be character type. Okay, so the data type, as we need to define any simple variable, we have to define it with the data type also. And then name of the variable, as in case of normal single variable, here also name of the variable is x or any name following the naming convention. And within third bracket, this actually indicate that size, that what will be the number of elements in that collection. So in for this program, since I need 9 elements, I am declaring the size to be 9. Okay. Now there are many more things. As initially I have said, when I declare a variable, normal variable, without initializing its any value, I don't have any clue what value is inside. That is called garbage values. Compiler has the flexibility to store any value inside. Although most of the modern compiler now initializes automatically with 0, but we don't need to rely on that. Some compilers may not do that. So we call them garbage because there are unknown values. Some values are there, but we don't know. So in order to alleviate that problem, usually we do like we give an initialization while declaring a variable. Okay. Similarly, when we declare an array without initializing, all the elements are having unknown values. Okay. We'll see how to
Right.
initialize these values and how to use or access, as I mentioned, that each of these elements or component of this collection can be accessed either for reading the value or updating their value, just like individual variables. For individual variables we can do, otherwise it will be useless. Okay, so this is one thing you should remember, that declaration is almost similar to the normal variable. Just like in case of normal variable, we have to mention data type, we have to mention name, and this is extra, the size, that how many elements will be there, how many members of that collection will be there, I need to mention within the third bracket or square bracket. Okay, now there are many more things we need to
Sir,
learn. Yes,
sir, can we use, sir, long integer, unsigned, or
everything,
normal?
everything. But
Okay,
that,
sir.
remember that data size should be same for all the elements. Okay,
Okay, sir.
so compiler, when it gets, just like for a normal variable declaration, compiler reserves suitable space for storing that data type. Here, what it will do, it will reserve sufficient space in the memory that can store the that many number of elements. Like when I declare int x9, that means it will internally, compiler will ask the operating system to reserve a space, a contiguous space. We'll talk about that later. What do you mean by contiguous space? But it is not only for single variable, it is 9 into size of integer. That means for a normal integer variable, only 4 bytes were reserved. Now here, for this, it will be 9 into 4. 36 bytes will be reserved. Understood? Just when I declare this one. Now let us come to the initialization or accessing part of the array. How it is done.
Sir, I have a question.
Hmm.
Sir, how it takes 4 bytes to store an integer, because it is, so say 1100, it is an integer.
Hmm.
Why I need 4 byte?
No, see, it size actually matters, that how large number you can store. As Joydeep sir has already described you, that how integers are stored in binary mode. See, if I take only 2 bits, huh, so I can either store 00, 01, or 10, or 11. If I have only 2 bit space, bit, not byte, then in decimal 0, 1, 2, 3. So if I consider unsigned number only, I can store at most 3.
Yes, sir.
Okay, now,
স্যার হোয়াট ইফ সাইন্ড ওয়াজ ইনক্লুড দেন?
huh,
সাইন ইনক্লুড থাকলে কতগুলো স্টোর করতে পারতেন?
sign include
2s,
2's
2s
complement, you need 0,
minus 1.
0. So positive side only 0 and plus 1. You see that most significant bit will be reserved for sign. So it will be plus 0 and plus 1 if I follow sign magnitude form, say. And this is 1, 0 and 1, 1. So minus 0, minus 1. Or if you use 2's complement form, then it will be like this 1, 0 will be saying, you have to take 2's
Minus 2.
complement of that. So one
Minus
more
2.
thing, instead of this plus 0 minus 0, there will be 0 plus 1 minus 1 minus 2, maybe these four numbers can be represented. So since we want large number to be handled, so we use 4 bytes. 4 bytes means 32 bits. So obviously you can imagine that larger space will allow us to deal with larger number. That's why.
Okay,
Clear?
sir. সে বলছি তাও তো একটা লিমিট থেকে যাচ্ছে, 32 বিটের বেশি
Obviously,
যদি নেই।
obviously there will be some limit. Always. You cannot do, see, in our paper and pencil, we have a limit on the width of the paper. isn't it? In machine, and that's the problem that you have. That is a practical problem we need to understand. Huh? So
Sir, we have
you
long
may
integer
think
format.
that okay, sir, so we cannot write any program which takes number larger than that can be represented in 4 bytes only. But there are ways. But obviously, the largest number you can represent will have always a limit. You cannot deal with infinitely large number with these finite sets of space. That limitation will always be there. Understood?
Yes, sir.
But
Yes, sir.
obviously there are some indirect way by which we can handle the numbers which can be represented greater than 32 bits also. Okay. But still that will be having some limit. We'll learn that later. But for the time being, you should understand that by default, our program should deal with data which can fit within 32 bits for integer. Okay.
Okay, sir.
Okay.
Sir, then by using array, can you calculate the sum of infinite positive integers?
Huh?
Can you calculate sum of infinite positive integers by using array?
A sum of infinite positive, as I've said, infinite is not possible. It can never be. If a series gets converged with some value, then only it is possible. It is not. If it's a diverging sequence, sum of that infinite numbers cannot be computed. You cannot
In
compute.
paper we can prove na
Hmm?
That
minus
that
1
one
by
is,
12.
I think that one is not integer. That one is fraction.
That's what I'm telling. I'm not
No,
talking about any
1 plus
specific
2
data
plus
type.
3, not fraction.
Huh?
Not fraction,
Are,
only positive natural
it
number.
is not infinity. It is
Natural
last term is
number sum
n.
of infinite, it is not possible. Yeah, you cannot
Last term
run
is
an
n.
infinite loop.
Yes, sir.
You cannot give infinite input also. You cannot write a program which can take infinite inputs.
In paper we
You
can
can do
calculate
it
na minus 1 by
finitely
12.
very large number of inputs you can deal with.
The last term is n. You said the last term is n, not infinity.
Yes.
N
Minus
tends to
1 by
infinity,
12
not
na.
infinity.
The
No,
answer is
no.
minus 1 by
Okay,
12.
let us
That's it.
not go into that
अरे
detail. So try to
सुदीप तो
first let us
Yes, sir.
assume
हेलो
Let's
that it is
continue,
not
sir.
possible right
Continue, sir.
now. Let us move
वो जो
ahead.
वो जो
Okay.
माइनस वो जो माइनस 1/12 होता है उसमें नॉर्मल मैथमेटिक्स नहीं लगता है तो ऐसा नहीं किया जा सकता सम ऑफ नेचुरल नंबर इज इक्वल्स टू -1/12 इट इज डिफरेंट
Okay, let us complete the discussion here first. I mean, don't. I mean, if we go so much uh, irrelevant points we discuss, then it will be very difficult to get the actual points right now. Okay, some of the things we may discuss beyond the class. If you are interested, you can discuss that. Okay, let us see. So my point was the declaration is this. Now we have not yet encountered how to initialize the value, how to access the individual elements. Okay, but one point as I mentioned, you should always remember that this collection should be made up of only data elements of same types. Clubbing of different types is not allowed. Okay, now this indexing, this is very important. So this collection is indexed. Index starts from 0. So this, as I have mentioned, this is a sequential collection. So when I declare 9 elements, a size of the array to be 9, that means there will be 9 elements placed logically sequentially, and each of the element will be indexed based on their position in the list. Like the first element or the leftmost element, you can say, is indexed by 0, not by 1. Remember, array indices start from 0. So since there are 9 elements, the index will go from 0 to 8. So first element index is 0, second element index is 1, and so on. So if any size, you assume any constant, say capital N is a constant. Now the last element will be indexed by n minus 1, not n. It is not 1 to n. It is not like that. It is 0 to n minus 1. That you should remember. Indices starts from 0 and ends at n minus 1 or size minus 1. Understood? And individual elements or individual member of this collection can be accessed by these indexes, like array name within third bracket index will allow you to refer the individual member or element of the array. That is very elegant method that almost all programming language allows, and also C allows. So if you say, if you want to initialize this value, so this fourth element, you want to put some value here, known value, you can just access it as a separate variable just by, since the array name is x and the index of that position is 3, if you write x3 equal to 5, then this will be overridden by 5. Are you getting my point? How the individual elements can be accessed.
Yes, sir.
So if you want to update this to -7, so just write x 0 equal to -7. So it will have -7 value. And that's why this is the very important strength of this feature. This is called random access, that you can randomly access, although this collection is sequential and their indexing is sequential, but you can use this mechanism. You can use any index which is valid, obviously within the range, to access. Access means either you can read, when you have got a value, you can also use that value on the right hand side of the expression also. Like if you want to now add these two values and you want to put that summation here, so you can also write x1 equal to x0 plus x3. This type of thing is also allowed. X0 you have already assigned -7 there, x3 you have already assigned 5 there, and now you are trying to add them, and that value you want to put in the second element. So this is also allowed. So what will happen? X0's value -7 and x3's value 5. So -2 will be assigned here. So see, this indexing helps you to refer individual elements of an array just like as an independent variable, x1 or x0 or x3, like that. This is the beauty of this feature. Try to understand. Got it? Got that feature?
Yes, sir. Yes, sir.
Okay. So let us see some more example, as I have already shown you, but formally let us see that how individual elements can be accessed, just like this one. X3 equal to 7, so this position will be overwritten. No, now it is known, this particular value. Similarly, this type of expression can be also used. But remember, this expression should be computed to an integral constant within the range 0 to size -1. So instead of writing direct constant value like x2, x3, x1, okay, you can write an expression, but that expression must be evaluated to an integral constant. You cannot use a floating point like that expression. If that expression say x 2.5, this is not allowed. Okay, because the you have to understand that meaning of this thing is it has to indicate one valid index of the array. So if your array you have declared has the size called size, this is the constant, say some value 9 or 90 or 999, whatever, this should be computed and should be within the range. That means that should be between 0 to 8 in this particular case. If that is outside, say if it is computed 9 or 10 or 11, then it is not allowed because there is no 9th or 10th or 11th element for this particular array. Understood? Similarly, it cannot be evaluated to an other data type except integer because indices can only be integer. Got the point?
Yes, sir.
Okay. I think
Yes, sir.
all of you should understand this. This is a very important thing.
So, sir, -4 is not valid here.
Huh? No, -4 is also not
Means,
valid. I mean only 0 to, so positive integer. So look at this index 0, 1, 2 up to the size -1. Okay. Negative out of the, I mean out of the range. Even if it is integer, if it is on the out of the range of your particular array you have declared, then it is not allowed. Not only negative allowed, for this particular array even 9 is not allowed, 10 is not allowed, anything beyond 8 is not allowed. Now if I declare an array say a 100, that means for that valid range is 0 to 99. So anything beyond that will be illegal. Understood? Not only negative, 100, 101, 102, any value beyond 99, even if that is integer, will not be allowed. The index must fall within the valid range of that particular array of our interest. Got it?
ইয়ে স্যার স্যার
Hmm.
দুটো স্লাইড আগে
yes,
দেখছিলাম যে স্যার আমি যদি স্যার x9 করে দিই তাহলে আমাকে এরর করবে না।
না, সেটা আসছি। I am coming to that. I have that's why I have called it illegal, huh? But not, it may not generate a compilation error. As okay, let me mention that. What he is saying, suppose you have declared this array size to be 9. Now I have said that I cannot use 10 or 11. But what may happen if you write like a statement and compile, your program may not generate any compilation error. Okay, but you may find some logical error in your program. Okay, why it is happening? Actually, what happens internal, I mean it will be very difficult for you at this moment to understand. When we declare an array of a particular size, we want that we need at least a contiguous space in the memory which can store 9 integers. Fine, but operating system usually allocates chunks of memory, that is called block, and for every machine there is a fixed block size, and that block size is not that much small. I mean it is not only 36 bytes or so, because the memory allocation process also needs some overhead. In order to uh, lessen the burden of overhead, actually chunks of very large like 512 bytes or 256 bytes or even 1024 bytes, this type of blocks are assigned. So what happens when we need only 36 bytes, maybe we are given more than 36 bytes. Okay, so even if we are going outside that bound, Actually, it is dependent on the operating system to check. Compiler, C compiler do not check whether you are going outside of the array or not. It leaves it to the operating system. And operating system generates error when you run the program. And sometimes it may ignore, because if it has already allocated 512 bytes, which is much greater than this 36 bytes, then there is enough memory, you can go outside, so it can just ignore. But what will happen, your program may generate some logical error. That means you may get some unpredictable result. Okay, so you should never try to do that. You should always remember that your limit is limited by 0 to size minus 1. Clear?
Yes, sir.
Okay, so even if it is not caught by compiler, or even if you during runtime operating system also ignores, but you should not do that, because you may get an unpredictable logical error, incorrect result. Your program runs successfully, but you may get a wrong result. That is very difficult to catch. So don't try to do that. Always remember that you have to go within the limited range. Okay.
Okay, sir.
Now, instead of initializing uh, individual array elements separately by issuing separate statements like x0 equal to something, then x1 equal to something, you can initialize the entire array within a single statement like this. Within curly braces, you have to put all the values of all the elements sequentially, like 5, 7, minus 4 separated by comma. Okay. Since there are 9 elements, you have to give 9 values sequentially. So this will go for 0th index, this is for 1, this is 2, this is 3. Understood? So instead of writing x0 equal to 5 semicolon, then x1 equal to 7 semicolon, x2 equal to minus 4 semicolon, instead of writing 9 such separate statement, you can club all the statements in a single statement for initialization of the entire array like this.
So,
Got
sir,
it?
arrays
Hmm?
arrays represent of a sequence in programming language.
Hmm? Hmm?
Sequence in mathematics, and it is a represent of sequence in programming languages.
Maybe. I mean, there are some more features and some difference, as the indexing starts from 0, you have to remember, and it is a random access. There are many ways you can represent sequence in programming. Okay, there are other data structures also, which you may not learn in this particular elementary course, but if you are from computer science, you will deal with programming a lot more. Then you may encounter several other options. Okay,
Yes,
but
sir, sir,
the
I have to
interesting
chase
point to
this.
note that the random accessness. Okay, although it is a sequence, but you can randomly access, go anywhere in the sequence, which may not be allowed in other kind of implementation of sequential elements. Understood?
Yes, sir.
Okay. So this is one way. Now, if you want all the array elements, this is a special option. Usually, most often, we declare an array and initially we want to initialize all the elements to be 0. Later on, depending on my requirement, I will update the values of the individual elements with something. So, for that limited, very specific use, this shortcut can be used. Instead of writing int x 9 equal to 0 comma 0 comma 9 times 0, you can use a single 0, but that is, remember, that is only for this 0. If you try to write like this int x say 9 equal to say 5, and that will not initialize all the elements with 5. That actually depends on compiler. Some compiler, in the most commonly, what it does, it will just initialize first element to 5, and then all elements will be initialized to 0. Okay, so don't try this one. Only if you want all the elements to be initialized with the value 0, then use this shortcut. Got it?
সে এরকম যদি 5 দিয়ে ছেড়ে দিই বাকি সব 0 হয়ে যাবে।
0 হয়ে যায় usually. It is actually, it is not written anywhere that what the compiler, how compiler should behave. There is no consistent behavior. In most of the compiler you may find this one. Some compiler may do your desired job. Okay, 5, all 5. Some may generate error. Okay, it is not it is not fixed. It depends on compiler to varies from compiler to compiler. That's why I recommend you don't try to use that. If you need to initialize all of them to 5, write 9 5s, or there is another shortcut I am showing you using a for loop. Okay, just like I'm showing you here, using a for loop, this one. So you can just write like this: for I equal to 0, I less than 9, I plus plus, then xi equal to 5, 6, whatever value you want, then it will be doing your job. Okay, so don't
ওকে
try to
স্যার।
use x9 equal to 5. Okay, don't use that. Instead use that. Understood? So for
কেন
loop
কি
allows you to initialize elements with different related values. Okay, this is one option. When you want that not all 0, not all 5, suppose 1 2 3 4 5 6, this type of initialization can be done using for loop very easily. Okay, so there are several ways, and you have to choose depending on your requirement. You have to choose the best one, and there are some limitation of some choices and some advantages of some choices, and it depends on your situation. You have to, through your experience, you have to learn which one you will be using at any particular case. Okay, now coming back to those two, as I've said, partial initialization is allowed. Like suppose you want to initialize only first 3 values, you can write this statement. But remember, this partial initialization must be contiguous from the left. Like you can either partially initialize only one element, or first 2 elements, or first 3 elements, or first 4 elements. If you want that, you want to only initialize these 2 elements, this type of thing you cannot write. Are you getting my point? The restriction, you cannot write like this unless you initialize all the, initialize partial initialization always be sequential from left. Do you understand the meaning of this particular statement?
ইয়েস।
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
and as I've said, this one, in your initialization, if you have presented more than 9 values, more than size number of values, then it may generate some warning. It's basically illegal. You should not try to do that. Compilers may not generate any error. Okay, but still it is not proper to use that. Always try to use, consider and respect the limit or valid range. Okay, don't put more than 9 elements in the initialization. So for loop, I have already shown how to use for loop in initializing. So you can use for loop to read the elements also. Just like we can update, if you want, suppose you want to get the values initialization values from the outside, from the user given initialization value. Then you can use the scanf statement within for loop and see ampersand x size, as I have mentioned several times in the array, this x within third bracket index, this is synonymous to a single variable. So just like for scanf, we had written scanf %d ampersand x1 say. Here I am writing this one. So this I value will get changed within the for loop. So first time it will ask for x0. So whatever first value user enters, that will enter here. Then next iteration of the for loop, value of I will become 1. So it will be equivalent to scanf %d ampersand x1. So whatever value user puts, that will put into this second position. So you can see how this is helping you to initialize the array with user given value. Just check it. Understood?
Yes, sir.
Okay. So lastly, you must know some other illegal operations. Like, although we can store the individual collection, I mean the collection of all the individual values within an envelope of array, but and we have seen we can refer individual members by indexing, and all whatever we can do in with the single variable we can do with those members separately. Initialization, accessing, reading, writing, updating, using in an expression, everything is possible. But with the entire array, okay, we cannot do we cannot treat the entire array as a single variable when doing most of the operations. Like we cannot read or print the entire array directly. Although I am saying it is a collection, I cannot write a printf statement, simple printf statement, that I know this is an integer type array. So if I write print, this is illegal. I cannot print the entire array. I have to use a for loop, and within that for loop I have to print them individual elements one by one to get the entire array to be printed. Okay, they cannot read, just like we have read individual elements using a scanf element enclosed within a for loop. So entire array cannot be printed, or entire array elements cannot be got by a single statement. Initialization is possible in some restriction, with some restriction, but reading or printing is not possible for the entire array. We have to do it element wise, either writing separate statements or enclosing them within a for loop or while loop, whatever. Okay, similarly we cannot assign the content of one array into another directly, even if they are of same size and data type. When we have two variables x1 and x2, we can write like this is legal when they are single variable. We can do it for individual array elements also, like x3 equal to x5, it is also allowed. But x equal to y, when both x and y are arrays of same data type, it is not legal. We cannot write like. Similarly, we cannot perform any arithmetic operation or logical operations on entire array directly. So although we are using a only single name to refer the collection, we cannot do most of the thing. We cannot assume that to act as a single variable. Okay, that we need to know. So we can consider the collection as a whole is only given to store the individual data properly, and we can use only one name instead of using so many names for different data items. And using indexing, we can get different names for different elements, and we can access and use them as separate variables. Okay.
Sir,
Yes.
sir, can we set variables in array like x5 equal to a b c d e f, and then
Yes.
put a equal to 10, a equal to
Yes.
5, b
Yes.
equal to
Yes.
5.
Yes. On the right hand side. Right hand side you can put any expression. Any expression using variable also. Yes. That is also right. Like you want to say that say int a is there, a variable. Now x5 you have declared x9 already, like this, and you have got
Yes, sir.
some value of a from the user by scanning it. That is allowed. That is allowed.
Okay, sir.
Hmm.
Sir, can
So
I let the user the control of the size of array?
hmm?
Can I let the user to control the size of array?
No, that's the thing. The traditional array, that is thing. The size of the array should be a constant and fixed when declaring the array. Okay. There are ways by which you can declare an array of size that will be given by the user. That is called dynamic arrays, dynamic memory allocation. We will discuss that later. Dynamic arrays. Okay. But from this array, I mean, this is static array we are dealing with right now. For there, the size should be constant, any constant. You can use, at most, you can use a symbolic constant. Instead of when you want to use the same array several times, instead of making a constant directly while declaring int x9, whenever you will be using this initialization or updation within for loop, you have to write 9 several times. If you want to avoid that, you can use a symbolic constant like this. That's all. But you cannot make the size to be a variable, and that variable will be got from the user, and accordingly the size of the array will be set during runtime. That is possible. That is possible. But we'll be dealing that later after we understand the dynamic memory allocation. Okay. For time being, you should assume that size must be a constant and known to the programmer earlier. It cannot be taken from the user. Obviously, some modern compilers, C compilers even allow you to do that. But the traditional C's recommendation of using the static array is that you have to define the size with a constant. Understood? So I will conclude by taking up that exercise. Now we know how to use array. So how do I change this? So instead of using this x as a normal variable, if we had used this as an array, we could have stored all the 9 elements within x, and
Yes, sir.
Yes, sir.
they they were not lost, so we can get back them just like this one. Let me take up this solution. Look at the solution. Then you may realize that how the use of the array helps us to effectively program for this particular problem.
Sir, SQRT কি স্কয়ার রুট এটা
Yes,
ডিফাইন্ড?
yes, yes. SQRT, and for that we see this. See, whenever you will use this type of already given function, this is just like printf scanf. This is also a function which is already defined in C compiler. Okay, square root, and for that you have to include this math.h. Remember, whenever you are using SQRT, if you don't use math.h, then when you go for compilation, it may generate error. And
ওকে
those
স্যার।
who are who are using Linux environment, okay, is there anybody who is using Linux environment?
Yes, sir.
So you must give this minus lm at the end of your command. Otherwise, this square root will not be linked. Usually you give what? GCC, then name of
Yes,
the
yes, sir.
C file.
Then,
So
then
after that, you should give this option minus lm. When you compile a program which is having sqrt, obviously you have to include math.h. Okay, but especially if you don't give this minus lm options, then that math.h will not be linked and the sqrt function will not work. Okay,
okay, sir. Sir, LM মানে কি?
this lm,
Yes, sir.
this minus lm indicates link math library. So what happens whenever these are the library functions? Okay, this printf, scanf, sqrt, all of them are library function, and the different library functions are clubbed in different way. Like this is math library, which holds several such functions. Not only sqrt, their definitions. Actually, these header files only contain their declaration, and already pre-linked pre-compiled library, their definition is already available within the compiler. So by default they don't get linked unless you especially force them to link in Linux. And in Windows, the compiler, whenever it gets this type of include statement, they automatically link math library. But in Linux, linking math library requires a special attention, special mention. Understood?
Okay, sir.
Okay, so I'm stopping here today. Hope you will.
Sir, I have a last question.
Okay,
Uh, sir, you have told that array is a স্যার ডাটা স্ট্রাকচার একটা অংশ, কিন্তু স্যার ডাটা স্ট্রাকচারটা কি যদি এক লাইনে বলেন?